In this video, we'll be looking at the solution to the JAMB Physics 2021 examination question 1 to 10. Question 1 here says, the force of repulsion between 2 point positive charges 5 microcoulomb and 8 microcoulomb separated at a distance of 0.02 meters apart is, take 1 over 4 pi E naught as equal to 9 times 10 to the power 9 Newton meter squared per Coulomb squared. You have your option A, B, C, and D. So how do we solve this question? Now for question 1, so I'll go to question 1. Question 1, for this question, we'll use Coulomb's law to solve this question. And from Coulomb's law, we have that F is equal to K Q1 Q2 all over R squared. This is the mathematical form of Coulomb's law. Now note that K can still be written as 1 all over 4 pi E naught. All right, the same thing there. Now what that means is that the formula F would have that F is equal to K, which is 1 all over 4 pi E naught dot Q1 Q2 all over R squared. So here's the mathematical representation of this. Now to solve this, we'll just impute our values. The value of Q1, your first charge is 5 microcoulomb, your second charge is 8 microcoulomb. So we'll impute those values. Meanwhile, before imputing Q1 and Q2, note that we're given the value of 1 over 4 pi E naught. Look at this. We said we should take the value of 1 over 4 pi E naught as 9 times 10 to the power 9. In essence, this whole value is 9 times 10 to the power 9. So we'll have the F is equal to 9 times 10 to the power 9. This is 1 over 4 pi E naught into Q1 is 5 micro. So 5 times 10 to the power, the value of micro is minus 6 coulomb, and then Q2 is 8 microcoulomb. Let's confirm that. Yes, 8 microcoulomb. So 8 micro is times 10 to the power minus 6 coulomb all over. So this all over square of the distance. So R here, R squared. Let's see their distance apart. What's the value? 0.02 meters. All right, so it becomes 0.02 in meters all squared. All right, so this is already in meters. I don't have to convert. Meanwhile, this one here was in microcoulomb. I converted to coulomb by multiplying it by 10 to the power minus 6. So that's it. All right, so let's see what you have here. So you get your calculator and punch this correctly. So let me pick my calculator and punch this real quick. So I'm going to punch everything at the same time. So numerator 9 times 10 to the power 9 multiplied by 5 times 10 to the power minus 6, that's micro, times 8 times 10 to the power minus 6 micro, all over, denominator is 0.02 squared. Now, if you punch this correctly with your calculator, your value gives you about 900 Newton. Of course, force is in Newton. So my answer here is 900 Newton. Looking at the option here, okay, these are in index form. 900, so 900, it's equal to 9 times 10 to the power from here becomes 2 Newton. And that is option C. So option C is the correct answer. All right. Question number 2 says the RMS value of a supply voltage is quoted at 200 volts. What is the approximate peak value of the voltage? A, 200 volts, B, 300 volts, C, 283 volts, D, 250 volts. So how do we solve this question? Now, you want to know that the meaning of RMS is simply root mean square, all right? So question 2, we want to know that RMS simply means root mean square. That's what RMS means. Now, when it comes to the concept of RMS and peak voltage, because you're asked to find the approximate peak value of the voltage, note that let's call the RMS voltage. Let's call RMS voltage Let's call this VRMS. Let's call the peak or maximum. Some years will tell you maximum. Peak or maximum voltage. Let's call this V naught or V max, any of them. Now, the relationship between these two is that VRMS, so note that VRMS is equal to V naught, that's peak voltage, all over root 2. So from here, if you're asked to find the value of the peak voltage, this is all over 1. So it becomes this times 1. You have that the peak voltage V naught is equal to VRMS root 2. So it becomes VRMS times root 2. So to get the peak voltage, simply multiply the RMS voltage by square root of 2. So let's see. The value of the RMS is 200. So it becomes 200 times root 2, and that's equal to 200 root 2. All right, let's punch this. 200 root 2. What's your value? That's about 282.84. And if you approximate this, this would be approximately, right, as a whole number, this becomes 283 volts. So this is the approximate value of the peak voltage, 283. Right, that is option C. All right, question number 3. It says heat transfer by convection will take place in one of the following substance: A, stone; B, wood; C, mercury; D, water. Now you want to note that heat transfer occurs by conduction, that's through solid. All right, you have the first one there called conduction, and usually in solid medium you have convection. This is in liquid medium, and then you have radiation, and this is basically through space or through air. All right. Now, when you say for convection, you want to note that what they mean is which of they are asking heat transfer by convection, that's liquid, will take place in which of the following substance. So when you look at which of this is a liquid, the correct answer there would be water. Right. So for this question here, the correct answer there would be water. So water is the correct answer. Question 4. A regular spacing or arrangement of atoms in a crystalline material is called A, orbit; B, lattice; C, atomic structure; D, energy level. Now, when we talk about a crystal, because they mentioned in a crystalline material, when we talk about a crystal, you want to note that a crystal is simply a piece of solid material in which the atoms or the molecules or the ions are arranged in a highly regular repeating pattern or lattice. Okay, a lattice is known as a pattern. So crystalline materials are arranged in something called a lattice. So for this, the correct answer there is B, lattice. So that's the correct answer. All right, next up, question number 5. Question 5 says the total resistance measured at PQ, that's this point here, that's the open point here, PQ, in the diagram above is, that's this diagram here: A, 18 ohms; B, 11 ohms; C, 4 ohms; D, 2 ohms. So how do you solve this question? Now, when it comes to solving question like this, I've already discussed the concept of this. What you have here are resistors, and I've discussed how you can resolve resistors in both series and parallel in our previous video. So check our JAMB playlist and you see a video on how you can resolve things like this. But for this question, how do you solve this? Now, in solving things of this nature or resolving circuits of this nature, you want to start from the closed end. That's this part here. This is called the closed end. You want to start from the closed end and resolve to this part. So you can see there's a space here. This is called the open end. So in essence, I will start from this point, let's call this A, and move to this point called B. This is how you resolve this. All right, let's get started. So how do you solve this question? The first thing you want to notice is that if I call this, let me call this resistor 1, let me call this 2, let me call this 3, let me call this 4, let me call this 5, and let me call this 6. The first thing you want to notice is that 1 is connected end to end to 2, and 2 is connected end to end with 3. All right. Now we don't say 3 is connected end to end with 4. No, why? Because it's a junction here. Look at this, a junction. So it's not a direct end to end. You don't also say that 3 is connected end to end with 6. No, why? Look at this, from 4, there's a junction here. So it doesn't work like that. So in essence, the ones connected end to end would be resistor 1, resistors 2, and resistor 3. All right. Now, when resistors are connected end to end, it's called a series arrangement. And for series arrangement, question number 5, let's get the equivalent of 1, 2, and 3. The equivalent of R1, R2, and R3. Since it's series, we'll call it R1, 2, 3. When I'm doing series, I'll simply add them up. That becomes R1 plus R2 plus R3. And that's equal to R1 is 2 ohm, R2 is 2 ohms, R3 is 2 ohms. So that becomes 2 plus 2 plus 2. And if I combine this, 2 plus 2 plus 2 gives you 6 ohms. So far so good. If I resolve all of this, I'll have 6 ohms. Now you want to note that again, after resolving them, the diagram will change. What would it look like now? This is what the diagram would look like now. So here's what you have. You'll have this now. Let's see. Oh, hold on, let me check. Let me confirm this diagram again. Oh, okay. So I'll draw it correctly. All right, so okay. So this way, then comes this way. I'll do a quick sketch of what the diagram now looks like. Okay, then this way, this way, this way, this way. And then this. So this is point P, this is point Q. I've resolved 1, 2, and 3. It will now come this way. You want to take notes how they draw this diagram. In essence, this is, let's confirm this was 5, 6, and 4. All right, this is 5, this is 6, this is 4, and this is the value of R1, 2, and 3. So this is where R1, 2, and 3 will position. Right? If you want to know why, please check out our class on resistors. I've explained this. Check our JAMB playlist for the lesson on resistors. I've explained why it will be positioned here. Now, from here, you want to observe that R1, 2, 3, that's this, is connected not in series, but in parallel with R4. All right? So R1, 2, 3 is in parallel with R4. Let's get the equivalent. Now, since it's a parallel connection, we'll take inverse. So we have 1 all over R1, 2, 3, 4. R1, 2, 3, 4 simply means the equivalent of resistor 1, 2, 3, and 4. Now that becomes 1 all over R1, 2, 3 plus 1 all over R4. This is the formula to get the equivalent of this and this when they're in parallel. Let's take value. For R1, 2, 3, the value is 6 ohms. So this is equal to 1 over 6 plus, for R4, let's see, the value of R4, that's resistor 4, the value is 3. So it becomes plus 1 over 3. All right. This is equal to, if I take LCM, the LCM here is 6. Now 6 divided by 6 divided by 6 is 1. 1 times numerator. 1 times 1 gives you 1. So I have 1 plus 6 divided by 3. That gives you 2. 2 times numerator. 2 times 1 gives you 2. If I add this, 1 plus 2 gives you 3 all over 6. Reduce to lowest term, it becomes 1 all over 2. In essence, we'll have that R1, 2, 3, 4. So I have 1 all over R1, 2, 3, and 4. It's equal to 1 over 2. To get the value of R1, 2, 3, 4, because we don't want the inverse, we want the actual value. So the actual value of R1, 2, 3, and 4, of course, this is inverse. To get the actual value, this one goes up and the 1 comes down. Then R1, 2, 3, 4 divided by 1 gives you R1, 2, 4. So we have this. So this value is equal to, for the answer, take 2 up, bring 1 down. Just invert them. So I'll be having 2 over 1. And we know that 2 over 1 is equal to 2. So I know that if I resolve from what we've done so far, if I resolve R1, and R2 and R3 and R4, I would have the value as 3 ohms. That's what we had, right? Okay, I'll have the value as 2 ohms. Look at this. That's what we have so far. So with this, we've now resolved R1, R2, R3, and R4. So what is left? What is left now is for R5 and R6, all right? Now, what will my new diagram look like? Because every time you make a resolution, you have a new diagram. For the new diagram, it's almost the same thing, just that I'll take this one off and this. So this one is off, and then this. This will no longer be R4. What we'll have here is now R1, 2, 3, 4. This is what the new diagram will look like. All right. Now, finally, you want to see that R1, 2, 3, 4, the equivalent resistance of resistor 1, resistor 2, resistor 3, and resistor 4 is in series. Look at this. This is in series with R5. Look at this. It's in series with R5, also in series with R6, as you can see here. So since they are in series, we can combine them. Now, if I combine them, you can see that nothing is left. So I'll have Aru total or Aru equivalent. All right, we call it RE, that's Aru equivalent, or RT, Aru total. Aru total becomes Aru 1, 2, 3, 4 plus R5 plus R6. And this is because they are in series, so I don't have to take inverse. The value of R1, 2, 3 is 2 ohms, so it becomes 2 plus, let's check the value of R5 and R6. Coming back to the question there, R5 is 1, R6 is 1. So it becomes 1 plus 1, 2 plus 1 plus 1. So if you combine this, 2 plus 1 plus 1 gives you 4. So it becomes 4 ohms. So the correct answer to this is 4 ohms. So let's see which option that is. That is C, 4 ohms. That's the correct answer. Okay, question number 6. Which of the following are true about infrared radiation? I, it is invisible. II, it is called heat ray. III, its frequency is higher than that of blue light. IV, it travels as a transverse wave. So which of the following is true? A, is it II, and IV? B, I, and IV only. C, I, and IV only. D, I, and IV only. What is the correct answer? Now, you want to know the following about infrared radiation. Number 1, it is invisible because it cannot be seen. All right, so it is invisible. That means I is correct. It's invisible. Again, it is called heat ray because it produces heat energy. In essence, II is correct. Yes, it's correct. Then also, you want to know that it travels as a transverse wave because it travels perpendicular to the direction of the vibration producing the wave. So in essence, IV, it travels as a transverse wave. That's correct. So these are the only 3 correct. So it becomes II, and IV. So which option is I, and IV? That's B. The correct answer here is B. I, and IV only. Question 7. Question 7 says, heat losses to the surrounding is possible through the following except A, conduction, B, convection, C, radiation, D, expansion. I already talked about this earlier when I said the heat losses to surrounding happen through conduction, convection, and radiation, right? So expansion is not part of it. So D, expansion is not part of it. All right, next up, question number 8. The dimension of universal gravitational constant is A. You have this, you have A, B, C, and D. Let's get universal gravitational constant and then we get the dimension. So first things first, when we talk about universal gravitational constant, what comes to mind? Now, when it comes to question 8, when it comes to universal gravitational constant, it's a constant for Newton's law of universal gravitation, which is mathematically expressed as F is equal to G m1 m2 all over r squared. Again, I have a detailed lecture on this on the YouTube channel. So you can check the JAMB playlist and you see a detailed lecture on this. Now, moving on, for us to get the dimension of G, the first thing we want to do is to make this capital G, which is called the universal gravitational constant, we'll make it subject to the formula. And to do that, that becomes this all over 1. So first things first, cross multiply this times 1 gives you G m1 m2. Of course, times 1 is itself. It's equal to F times R squared gives you FR squared. So I have F, and that gives you R squared. Now to get the value of G, all I have to do is divide here by m1 m2. That's m1 m2. Divide here by m1 m2. Of course, this cancels this. So G will be equal to, have that G will be equal to F R squared all over M1, M2. You have this. All right. So when it comes to getting dimension, what that simply means is that you want to express each of these quantities. F is force, R is distance, M1 is your first mass, M2 is your second mass. You want to express this in terms of mass, capital M, length, capital L, and time, capital T. Let's start with force. We know that force, F, is equal to mass times acceleration. Mass is a capital M. Acceleration, the unit is meter per second squared. Meter is the unit for what there? Length. Seconds is the unit for what there? Time. They have raised to power minus 2. So time to power minus 2. This is the dimension for force. So MLT to power minus 2. Let me take this off. So force is MLT. So force alone is MLT to power minus 2. When it comes to R, we said R is distance, and distance is simply a length. That becomes L. Now distance is squared, so it becomes L squared all over M1 is your first mass, so capital M, dot M2 is the second mass, so just keep it as M, so stay M there. Now, on working on this, you have that M will cancel M. By the way, I've also explained this under the topic called dimensions or dimensioning, also on this YouTube channel. Please check the JAMB playlist. All right. Moving with this, this is simply, if this cancels out, you're left with, you having L here times L squared. That gives you L cubed. So I have L cubed. Then you have this one here, T to power minus 2. T to power minus 2 all over, you're left with M here. So all over M. Now working on this, expressing all of this here in index form, this M is a denominator. So it becomes M to power minus 1 since it's a denominator. The next up you have L squared. So L, you have L cubed. That's L cubed. Then T to power minus 2. So you have this. So the dimension, there is M to power minus 1, L cubed, T to power minus 2. So let's see which dimension matches this. M to power minus 1, L cubed, T to power minus 2. So I think that's actually A, but they added an L. So it's not an L. Just take off this L here. So this is correct. M to power minus 1, L cubed, T to power minus 2. That's the correct answer. So we'll take A as the answer. But just note that L should not have been there. Right? It's a typo error. So the answer there is A, M to power minus 1, L cubed, and T to power minus 2. That's the correct answer. Okay, next up, let's look at the next question there. Question number 9. Question 9 says, which of the following cannot be used to explain the laws governing reflection? A. Formation of image by plane mirror. B. Formation of image by curved mirror. C. Action of the periscope. D. Formation of shadows. So which of these is the correct answer? For this question here, the correct answer is D, the formation of shadows. And this is because shadows are produced by the obstruction of light by an opaque object. So when an opaque object obstructs light, by opaque we mean an object that does not allow light go through it or pass through it. So when an object that does not allow light pass through it blocks out light, what happens there is that a shadow is being formed. Now, it obstructs the light rays from the sun and prevents getting to the area of shade. So what the opaque object does is that it prevents light rays from getting to the particular area which it is shading. So hence the answer becomes D. The formation of shadow cannot be used to explain the laws governing reflection, since light rays does not get to the surface due to an obstruction from an opaque object. All right. Okay, next up, question 10, the final question for this video. Question 10 says the ratio of electrostatic force Fe to gravitational force Fg between two protons, each of charge E and mass m at a distance d is, you have option A, option B, option C, and option D. So how do we solve this question? So question number 10, ratio of electrostatic force Fe, that's this, to gravitational force Fg will be equal to, let's analyze this a bit. When we talk about electrostatic force, what comes to mind is Coulomb's law. And from Coulomb's law, we know that the formula is K Q1 Q2 all over R squared. We have this. Also, the question said that each of charge E, so I'll change Q1 and Q2 to E and E. So we'll have Fe is equal to K. The first charge is E. The second charge is E. All right, all over R squared. Multiplying this becomes K. E times E is E squared all over R squared. So we'll have this. And don't forget that, as we said earlier, K is equal to 1 over 4 pi E naught. We mentioned this earlier. I think this was question number 1. Yes, we use this in question number 1. So if you impute this value, this will be equal to K becomes 1 all over 4 pi E naught multiplied by E squared. So E squared all over R squared. Multiplying this, what do we have here? We have that Fe is equal to 1 times E squared gives you E squared all over 4 pi E naught times R squared gives you 4 pi E naught R squared. This is the value of Fe. Let's now get Fg. So Fg, which is gravitational force, Fg is equal to, your formula there is G m1 m2 all over R squared. This is from Newton's law of universal gravitation, and that becomes G. The value of m1, they said each of mass m. So m1 becomes m, m2 also becomes m, since they are the same thing with the same mass, all over R squared. Now let's multiply this. This becomes G into m times m is m squared all over R squared. So what I have here now becomes the formula for Fg. They said ratio of Fe to Fg. That simply means Fe, right? If I have Fe over Fg, that is same as saying Fe divided by Fg. It's the same thing. So let's divide this. This is equal to, for Fe, we have this as E squared. So E squared all over 4 pi E naught R squared divided by Fg. Fg is Gm squared, that's G m squared all over R squared. So work on this. This is equal to E squared all over 4 pi E naught R squared. Division becomes multiplication, so it becomes times. This goes up and this comes down. That becomes R squared all over G m squared. Now this is equal to R squared cancels R squared. This gives you 1 and this gives you 1. No, nothing can cancel here. So let's multiply numerator. E squared times 1 gives you E squared all over. For the denominator, I have 4 pi E naught, 4 pi E naught Gm squared gm squared. So 4 pi e naught all over, so e squared all over 4 pi e naught gm squared. So let's see, do we have any option like that? So looking at the options here, obviously the correct answer is option A. So option A is the correct answer, which is e squared all over 4 pi e naught gm squared. Yeah, that's the correct answer. Question 11 says, a man wears convex lens glasses of focal length 30 cm in order to correct his eye defect. Instead of the optimum 25 cm, his least distance of distinct vision is A. 14 cm, B. 28 cm, C. 75 cm, D. 150 cm. So how do we solve this question? Let's take down question 11. So for 11 there, we are given the focal length, that's small letter f. The focal length is given as 30 cm. That becomes 30 cm there. Next, they said, in order to correct his eye defect, instead of the optimum 25 cm. Now, this optimum 25 cm here, what it represents is simply the object distance. So take u as equal to 25 cm. Now, your asked said his least distance of distinct vision is, right? So what that means is simply your image distance v. You have to find the value of v. So that's for this question. Now to solve this, obviously we have to use the mirror formula. So we have that the inverse of the focal length is equal to 1 over u plus 1 over v. Right? So inverse of focal length, it's equal to inverse of 1 over v. So we have that from the mirror formula. This is called the mirror formula. We'll have that the inverse of the focal length is equal to the inverse of the object distance plus the inverse of the image distance. Let's impute values. So I have 1 all over, the value of f is 30. It's equal to 1 over the u, which is object distance, is 25, plus 1 over v. V there is image distance. Now to get the value of v, what we'll do here is very simple. This is equal to, of course, I have to move 1 over 25 over here. So I'll be having 1 over 30. This is positive. Crosses equality sign becomes negative, minus 1 over 25 is equal to 1 over v. Now from these two here, let's take LCM. If you take LCM, let me take this first. I'll have that 1 over V is equal to, for 30 and 25, the LCM of 30 and 25 is simply 150. So I have an LCM there of 150. Now to solve this, of course, 150 divided by 30, that gives you 5. 5 times numerator, 5 times 1, that gives you 5. So I have 5 minus, next up, 150 divided by 25. And if you punch that, 150 over 25, that gives you 6. 6 times numerator, 6 times 1 gives you 6. Now solving this further, what you have here is, you have this one here, 1 over v. So 1 all over v, it's equal to 5 minus 6. 5 minus 6 is minus 1 all over, I have this as 150. Right, now to solve this, take v to the numerator, take 1 down, right? That's invert them, so it becomes v over 1. So v over 1 is equal to, take 150 up, take minus 1 down. It becomes 150 all over minus 1. This would give you v over 1 gives you v is equal to 150 divided by minus 1 gives you minus 150. So basically you have that v is equal to minus 150 in centimeters. The actual value of v would be equal to 150, right, in cm. You have this. Right, so you have this. But then the negative here simply implies that the image is real and inverted. That's why you have a negative. But the actual value is 150 cm. So let's see which option gives us 150 cm. Let's look at this. So looking at this, the answer there is D, 150 cm. Next question, number 12. Question 12 says, images formed by a convex mirror are always dash. A, virtual, erect, and diminished. B, virtual, real, and erect. C, magnified, diminished, and erect. D, virtual, diminished, and magnified. For this question there, the correct answer is A, right? So note that images formed by a convex mirror are always virtual, erect, and diminished. Next up, question number 13. 13 says, a steel wire of length 0.5 meters is stretched between two fixed points and its fundamental frequency is 200 hertz. The speed of the wave in the wire is A, 100 meter per second, B, 120 meter per second, C, 200 meter per second, D, 250 meter per second. So how do we solve this question? First things first, for question number 13, we want to list out the parameters we have. From here, they give us length as 0.5 meters and then frequency as 200 hertz. So length L as equal to 0.5 meters, frequency F as 200 hertz. So 200 hertz. This, and we are asked to find what's that. Let's see again. We have to find the speed of the wave. So how do we find speed of the wave? Now, for this question here, note that if you're given length and frequency, and you're asked to find speed, you want to note that the formula that relates all three, let's say speed V, it's equal to unknown. The formula that relates these three parameters is that frequency F is equal to the ratio of speed to twice the length, right? So F is equal to V over 2L. The value of F is 200 is equal to V all over 2 times L. The value of L is 0.5. Okay, proceeding with this, this would give you, this is 200. So 200, it's equal to V all over 2 times 0.5. That's 2 times half gives you 1. Obviously, V over 1 here, from here, V over 1, this gives you V. So 200 is equal to V. Or we can say V is 200. Of course, this would be in meter per second. That's speed or velocity. So V is 200 meter per second. And that's there is option C, 200 meter per second. Question 14. 14 says, which of the following can be used to reduce local action in a Lagrangian cell? A carbon rod as the positive pole. B, pure zinc as the negative pole. C, potassium permanganate solution in contact with the positive pole. D, common salt solution. So how do we solve this question, or what's the answer to this question? The correct answer to this question is C, potassium permanganate solution in contact with the positive pole. That's the correct answer. And before I explain this, you need to understand what local action means. So when they say local action, this is simply an unwanted side reaction of a cell where impurities in the zinc electrode reacts with the electrolyte, causing corrosion and reducing the cell's efficiency. So local action literally reduces the efficiency of a cell. To reduce this, we use potassium permanganate solution in contact with the positive pole. And this is because by adding potassium permanganate to the positive electrode, by positive electrode, we mean the carbon rod, it acts as a depolarizer, meaning it helps to prevent the buildup of hydrogen gas on the electrode. Thus, it reduces the local action. So that's why the correct answer to this is C, potassium permanganate solution in contact with the positive pole. All right. Next up, question number 15. It says, convert 45 degrees Celsius to Kelvin. Right. A, 318 Kelvin. B, 250 Kelvin. C, 184 Kelvin. D, 120 Kelvin. So what is the correct answer to this question? Now, here's a very simple question. All we have to do is, you know that your value x in degrees Celsius is equal to, for Kelvin becomes x plus 273 in Kelvin. All right. So what that means is simply add 45, just add 273 to the value and see what we get. So if you point 45 plus 273, the value is 318 Kelvin, 318 Kelvin. All right, so that's it. So basically, the correct answer here is A, 318 Kelvin. It's that simple. Next up, question 16. Which of the following scientific instruments or tools is used to measure accurately to two decimal places in centimeter? A. Meter rule. B. Vernier caliper. C. Micrometer screw gauge. D. Measuring cylinder. The answer to this question here for 16 is B. Vernier caliper. So you want to note that the vernier caliper is a scientific instrument or a scientific tool which is used to measure accuracy to or accurately to two decimal places in centimeter. All right, so take note of this. Let's proceed. Question 17. Which of the following will increase the boiling point of water? 1 or I, taking it to a high altitude. II, dissolving a salt into it. III, heating it in a sealed flask. IV, increasing the rate of heat supply. A, I only. B, III and IV only. C, II and III only. D, II only. So looking at the question here, they're asking you which of these from I to IV, which of them will increase the boiling point of water? Taking it to a higher altitude means taking water to a higher height. Now, irrespective of the height, the boiling point of water will still be 100 degrees Celsius. So that's it. So this does not change anything. IV4 says increasing the rate of heat supply. By increasing the rate of heat supply, that means just increasing the temperature. And increasing the temperature only means that the water or water will get to its boiling point faster. It does not increase the boiling point. It just means that the rate or the speed at which water gets to its boiling point will still be the same thing. All right. III says heating it in a sealed flask. If you heat it in a sealed flask, it might delay, or depends on the material used to make the sealed flask. It might delay water from getting to its boiling point, but water will eventually get to its boiling point. So heating it in a sealed flask changes nothing. Meanwhile, IV says dissolving a salt into it. Now, the correct answer here will be IV, dissolving a salt into it. And this is because if you dissolve salt into it, the water becomes impure. And we know that the boiling point of pure water and impure water, they are different. So if I dissolve salt into it, I'll make the water impure. And because of the impurity in the water, the boiling point will be increased. So the answer becomes II only. D is the correct option. Question number 18. A good electric cell should have which of the following? A minimum of polarization effect. B, a long life. C, a cheap and safe electrolytes. D, all of the above. And the correct answer to this 8 would be all of the above. All right. So you want to take note that a good electric cell would have a minimum polarization effect. Yes. Should also have a long life. That means it should last longer. Yes. It should also have a cheap and safe electrolytes. That means the electrolyte should not be that expensive, and of course, it should also be safe to use. In as much as it is cheap, it shouldn't be hazardous or disastrous. It should also be safe to use. So, in essence, all of the above is the correct answer. Question 19. What is the angle of dip at the magnetic equator? A, 180 degrees. B, 90 degrees. C, 45 degrees. D, 0 degrees. Now, this is under the topic magnetic field, all right? For the correct answer here, the correct answer is B. It's at 90 degrees, all right? So 90 degrees is the angle of dip at the magnetic equator, all right? So you can check the video or your text on magnetic field and you see more explanation on this. Finally, question 20. The eyeball consists of a round, tough white skin called A. A. Sclerotic. B. Choroid coat. C. Optical fiber. D. Accommodation. The correct answer to this question is A. Sclerotic. All right. Now, here's something you should know. The sclerotic or the sclera, that's this. The sclera is the tough white outer layer of the eyeball. It is made up of fibrous connective tissue and provides protection and structure of the eye. All right, so the correct answer here is A. Question 21 says, which of the following is not a luminous object? A, the sun, B, the moon, C, light candle, D, star. Okay, so which of the following is not a luminous object? To answer this question, we must first of all understand the meaning of the term luminous object. So when we say luminous object, what exactly do we mean? You want to know that a luminous object is one that gives off light. In other words, it glows or shines of its own accord. Now, to be able to glow, the object must have its own source of energy. All right. So if you look at these options here, A, of course, the sun produces its own source of light, right, or heat energy. So A, the sun is a luminous object. When we talk about candlelight, now, if I light up a candle and I place it in a dark room, you'd agree that this candle here can light up the entire dark room on its own. That means even when I take off the light source or the heat source, you see that the candle will be able to stay on its own and light up the room. So it's a luminous object. The same thing with the stars. All right. Stars also produce their own light, but not the moon. Right. The moon is not part of it. The moon does not give off its own light source, but only reflects the light source from the sun. So hence, A, the moon is not a luminous object. That's it. Next up, 22. A simple pendulum of mass 50 gram oscillates with amplitude 4 centimeter, period 2 seconds. Determine the angular velocity. Assume pi to be equal to 3.14. All right. You have your options there. Option A, 3.14, B, 1.34, C, 6.14, D, 3.21. So how do we solve this question? For 22, let's list out the parameters. 22, the first you're given there is the mass M. They said the mass is about 50 grams. So mass M, 50 grams. You have 50 grams. Next up, they said oscillates with an amplitude 4 cm. So you have the amplitude there. A as equal to 4 cm. Next up, they said the period is 2 seconds. So time T is equal to 2 seconds. In this question, you're asked to find the angular velocity. So angular velocity, as we know it, is omega, and that's equal to unknown. For this question here, you want to note that the relationship between angular velocity, omega, and the time there, or period, is equal to 2 pi all over t. You have this. In essence, we can find the angular velocity from the period by using the formula 2 pi over t. If I put in values, this becomes 2. You're asked to take pi as 3.14, this all over t. T is 2 seconds. From here, we can see that 2 can cancel 2, and you have your answer as 3.14. Your unit for angular velocity is rad per second. So you have 3.14 rad per second. So let's see which option has 3.14 rad per second. That's A, although the unit was not given, but your answer is A. 23. 23 says, in a closed organ pipe producing a musical note, an antinode will always be produced at A, the closed end, B, the open end, C, the middle, D, all the parts of the pipe. So what's the correct answer to this question? Now, to answer this question here, you need to note that in a closed organ pipe, an antinode, right, would always be produced at the open end. And this is because air can move freely there, resulting in maximum displacement. So the correct answer to this question is D, open end, B. That's your correct answer. All right, question number 24. 24 says, estimate the fall in the height of mercury Coulomb where the barometer is sticking vertically upwards through a height of 1 kilometer. All right, you're given the density of mercury as equal to 1,300 kilogram per meter cube and the density of air to be 1.3 kilogram per meter cube. Option A, 0.1 meters. Option B, 0.5 meters. Option C, 0.3 meters. Option D, 1 meter. So how do you solve question number 24? To solve question number 24, let's pick up parameters. Right? For 24, what and what are we given there? Let's see what we're given here. They said estimate the fall in the height of mercury. So you have height of mercury here, Coulomb, where the barometer is taking vertically upwards through a height of 1 kilometer. So the height of mercury there is. Now to solve this question, we need a particular formula for 24. Now to solve this particular question, we need a formula for 24. For 24, when we talk about change in height and pressure, now this is under the topic pressure, all right? And for pressure, we know that pressure P is equal to force all over area basically. But pressure can still be expressed as the product of density times gravity times height, all right? I've already explained this one in our previous video. So check our playlist, our video on pressure under the JAMB playlist. You see how we derive pressure as rho GH. But for this question, if you look at what is mentioned here, they mentioned, let's look at this again. They mentioned mercury. They also mentioned air. Look at this. So you can see mercury and air. Now, to balance this up or to solve this question, we'll take that the change in pressure of mercury, the symbol for mercury is Hg. All right. So have that the change in pressure of mercury is equal to the change in pressure for air. So you have this. Now, owing to the fact that pressure is rho GH, we have that the change, this becomes pressure here is rho GH. We know that when it comes to rho GH here, density is always a constant, it does not change. Gravity is also a constant, it does not change, but height can change. So in essence, what we're having here is the density of Hg mercury multiplied by G gravity and then change in H of mercury. So you should know why I'm taking change in H and not change in Hg. Change in Hg here, this one here, change in the density of Hg simply means change in the density of mercury. But we know that mercury is, or density, that's this, is always a constant, so it will not change. So the only thing that can change between density, gravity, and height is height. So this change here goes to height only. That's the concept. This will be equal to density of, for here we're using air, so density of air times gravity times change in height of air. So put this as this of air. All right, so we have this. Now looking at this, we can see that we have G and G on both sides, so they cancel out. So for this question here, we are simply asked to find the change, estimate the fall in the height of mercury. So we're looking for the change in the height of mercury. That's change in height of mercury becomes divide this by density of mercury, or Hg, divide this by density of mercury. So we'd have our formula as the change in that height or the fall in height being equal to density of air times change in height of air all over density of mercury. Let's impute the values. What is the density of air as given the question? Density of air is given as 1.3. So we're having this as 1.3. It's equal to 1.3 density of air times the height. They said it falls through a height of 1 kilometer. 1 kilometer is 1,000 meters. It becomes 1,000 in meters all over density of mercury. The density of mercury, let's see what we have here. Density of mercury is 1,300. So it becomes 1,300. Working on this, 1.3 times 1,000 gives you 1,300. So you have 1,300 divided by 1,300. Of course, if you cancel this, this will be equal to what there? 1. So you have this. So this is change in height of mercury. It becomes 1 meter. All right, I think they're using meter there for height. Let's see. Yep. So the answer is D, 1 meter. So the correct answer here is D, 1 meter. So this is how we solve this question. Next up, question number 25. 25 says, what is the coefficient of friction between a wood of mass 1.6 kilogram and a horizontal surface. If the limiting frictional force is 8 Newton, A 0.2, B 0.9, C 0.5, D 0.6. So how do we solve this particular question? Now, to solve this question, we want to recall the formula that frictional force F is equal to the coefficient of friction times the normal reaction. We have this. So if you're asked what is the coefficient of friction, you're asked to find the value of mu. And to get mu, divide here by normal reaction, divide here by normal reaction. This cancels this. So mu, which is coefficient of friction, would have that mu, this is equal to frictional force all over normal reaction. And that's equal to frictional force all over. The normal reaction can still be expressed as the product of mass and gravity. Now with this, let's put in values. This is equal to, what is the value of the frictional force? They said if the limiting frictional force is 8 Newton, so the frictional force is 8 Newton, so it becomes 8 all over. When it comes to M, which is your mass, the value is 1.8 kilogram, so mass of 1.8. So mass is 1.8 times the value of gravity. Let's use 9.8 here. So this gives you 8 all over. I'll pick up my calculator. I'll punch 1.8 multiplied by 9.8. And that's about 17.64. So I have 17.64. If I do the division, 8 all over 17.64, that's about 0.45, approximately 0.5. That's my answer. So let's see if we have any option as 0.45 or 0.5. Okay, so looking at the option, we can see that the correct answer here is C, 0.5. And of course, this has no units, okay? You want to take note that the coefficient of friction has no SI units, so it's just 0.5. Let's look at the next question number 26. All right, next up, question number 26. 26 says, what is the relationship between mechanical advantage MA, velocity ratio VR, and efficiency E with percentage? Now, for this question here, 26, you want to note that the relationship there is that efficiency E is equal to the ratio of MA, mechanical advantage, to VR, velocity ratio, expressed as a percentage. So all over 100%. So the answer there is E. It's equal to MA all over VR times 100%. So do we have any option like that here? Let's see this. No, not really. So there's no correct option, although B looks good, because from B, if I cross multiply, becomes M. This is all over 1, of course. So MA times 1 becomes MA is equal to E times VR, gives you E dot VR. So if this was an exam situation, I would most likely pick B, but it said with percentage. So it should be this times 100%. So if this was to be exam, I would just go with B. So MA is equal to E times VR. That's correct. Of course, times 100. So with percentage, so perhaps times 100%. So that's it. Next up, question 27 says, Mr. Roland observed his image through a plane mirror, kept a distance away from him at 4.7 meters in his room. At what distance is the image found from Roland's eye? A. 9.4 meters, B. 7.5 meters, C. 5.7 meters, D. 6.9 meters. So how do you solve this question? Now, let's try to get this in diagram form. Observe that they mentioned a plane mirror, all right? That's this, a plane mirror. Now, plane mirrors are simply the kind of mirrors we use in our houses. Here's something you should note about a plane mirror. Let's say this is my surface level, all right? And you have a plane mirror somewhere here. Let me just put this way and put this as a plane mirror here. If Mr. Roland stands at this point, right? Let's say he's standing here and he looks at a plane mirror like this. This plane mirror here, so this is Mr. Roland, he's the object. This plane mirror will form an image of Mr. Roland somewhere behind the mirror like this. So have something like this. What you want to notice is that if the distance from this is the image, let's call this I, all right? I is image, O is object. The distance between Mr. Roland, that's this, and the mirror, that's this. Let's call this distance A. This A here will be the exact same image between the mirror and the image. That's this. You have this as A. You have the same distance. In other words, for a plane mirror, don't forget we said this is a plane mirror. A plane mirror. The idea here is that for a plane mirror, the image is formed at the exact same distance of the object from the mirror. That's the concept. Now, if that's been said, they said Mr. Roland observed his image through a plane mirror, kept a distance away from him. So distance between him and the plane mirror is 4.7 meters in his room. So let's say this. That means from here, Mr. Roland, the object from here up to your plane mirror, that's here, which is of course this one here, taking this, all right, it's about 4.7 meters. If this is 4.7 meters, we know that the image that's here will be formed at the same distance, 4.7 meters. It will be the same thing. That's why it's a plane mirror, all right? That means the image distance and the object distance will be the same thing. Also, the image size and the plane and the object size will also be the same thing. All right. Image distance and object distance will be the same. Also, image size and object size will be the same thing. Now, with this being established, what's the question? They said, at what distance is the image found from Mr. Roland's eye? Where is Mr. Roland's eye? Of course, his eye would be somewhere around here, which is the same thing as his position. That's this point. Let's call this A. They're asking you, what is the distance of the image? The image is at this point here. So from A to B, what is the total image? It simply becomes this image here, 4.7, plus this one here, 4.7. So it becomes 4.7 plus 4.7. So 4.7 plus 4.7, and that's equal to 9.4 meters. All right. So let's see which option matches that. That's option A, 9.4 meters. So this is the correct answer. All right. Question number 28. 28 says the reason why water is never used in thermometer is because A, it freezes at 0 degrees Celsius and boils at 100 degrees Celsius. That is, it has a small range. B, it expands uniformly when used. C, it does not expand uniformly. D, none of the above. All right. So why is water never used in a thermometer? What's the reason? Now you want to note that the reason why water is never used in a thermometer is because it freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And for a thermometer, we also want to measure temperature lesser than or lower than 0 degrees Celsius, perhaps -3, -17 degrees Celsius. And at that point, water would freeze. So water is therefore not suitable. So in essence, the answer there is A. It freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And because of that, the range is just too small. All right. Next up, question 29. The most suitable type of mirror used for the construction of a searchlight is the A, concave mirror, B, convex mirror, C, spherical mirror, D, parabolic mirror. Now for this question here, you want to note that for a searchlight, right? For a searchlight, you want to note that usually a searchlight is usually this curved, right? This way, this curved. You have this, it shines this way, very bright like this. And this is only possible because the mirror has to be in this form here like this. And this is a parabola. All right. So the correct answer there is D, parabolic mirror. That's D. Finally, question number 30. 30 says a good electric cell should have 30 says a good electric cell should have which of the following? A minimum of polarization effect. B, a long life. C, a cheap and safe electrolyte. D, all of the following. So I think this question has been repeated in this year. We already answered this previously. So the answer here, as we said previously, is all of the above. This question is actually repeated. All right. Yes, so we said a good cell should have, of course, it should have a minimum of polarization effect. And of course, it should last long. That means it should have a long life. And of course, the material should be cheap. And while it is cheap, it should not be hazardous. That means it should be cheap and safe, or you should have cheap and safe electrolytes. That means the correct answer is all of the following, or all of the above. Question 31 says, if an object whose mass is 3 kilogram moves in a circular path of a radius 0.7 meters, records a speed at 2 meters per second, what is the result of the angular velocity? A, 4 rads, B, 1 rad, C, 3 rads, D, 5 rads. So how do we solve this question? Question 31. All right. If you look at what we're given there, the first thing we're given that they said an object whose mass is 3 kilogram. The first we're given the mass m, it's equal to 3 kilogram. They said moves in a circular path of radius 0.7 meters. You're given radius r as equal to 0.7 meters. What else? They said records a speed at 2 meters per second. So you're given speed, that's v, velocity, as equal to 2 meters per second. You have this. You're asked to find what is the result of the angular velocity. We know that angular velocity is represented by omega, and that's equal to unknown. Now, to solve this, you want to record that there's a relationship between linear velocity, v, and angular velocity, omega. And that relationship is that v is equal to omega times r. All right. You want to know that linear velocity is equal to angular velocity times radius. In essence, if you have angular velocity to get the, if you have linear velocity to get angular velocity, divide here by r and divide here by r. This cancels this. So we have that angular velocity omega is equal to v all over r. Let's impute values. This is equal to v is 2 all over r is 0.7. All right. And if you do this, this will give you about 2.8. 2.8. Angular velocity is measured in rad per second. Approximate this to the nearest whole number. That gives you 3 rad per second, where rad is simply radians. So the answer there is 3 radians per second. So for 31, the answer is 3 rads per second. Option C. That's the correct answer. All right. Question 32. The correct shape of the graph of UV against in brackets U plus V for an object distance U and image distance V in an experiment to find the focal length of a convex lens is given as. So you have option A, B, C, and D. So which of these is correct? Now, they talk about focal length, and we want to recall that the formula that connects U, V, and F, focal length, is the mirror formula. So from 32, you have the mirror formula as 1 over F is equal to 1 over U plus 1 over V. Here's your mirror formula. And if we work on this, we'll have 1 all over F is equal to, now with this, for these two, we'll take the LCM there. The LCM is obviously UV, right? UV divided by U, that gives you V. V times numerator 1, that gives you V. So have V plus UV divided by V will give you U. U times numerator, U times 1 gives you U. And we know that we can rewrite V plus U. It can still be written as U plus V, and that's correct. So I'll just come here and change this from V plus U. I'll change this from V plus U to U plus V. It's the same thing, all right? All right, so we'll have that 1 over F is equal to U plus V all over UV. Proceeding with this, would have that if I cross multiply, 1 times UV gives you UV is equal to F times U plus V gives you F into U plus V. All right, so if you look at this, you know that this is similar to a straight line equation. Don't forget that for a straight line equation, you have that the equation is simply y is equal to, sorry, you have that y is equal to mx plus c. This is the equation of a straight line. If I relate this to that, to this equation here, you have that y is something as uv is equal to m becomes f here. That's f into the x-axis becomes u plus v plus, now observe there's nothing here. So that means the c there becomes 0. That means we said c simply represents the intercept on the y-axis. So if it's 0, that means it passes through the origin. In essence, I'll plot a graph this way. I'll plot a graph this way where the y-axis is uv. So uv this way. The x-axis is u plus v. That becomes this as u plus v. Since c is 0, it means it has no intercept. It goes through what's there. It goes through the center that passes through the origin, something like this. So we'll have this as the correct answer. So the graph of uv against u plus v, that's y against x, will give you this. It will give you this, and note that the slope would simply represent what there? The focal length, f. So let's see. Graph of uv against u plus v will give you a slope of the focal length. Let's go back to the question there. So they said the correct shape of the graph of uv against u plus v, which we've done, right? So which of this is correct? The answer will be C. Now C, because this one passes through the origin, observe, right? It would have been D, but D does not pass through the origin. D has an intercept, which means it has a value for C. But recall that we didn't have a value for C. So the answer here is C, this value here. Passes through the origin. That's the correct answer. All right, next up, 33. 33 says, Lodestone is a natural magnet. It points at A, northwest when suspended freely, B, north-south when suspended freely, C, southeast when suspended freely, D, southwest when suspended freely. For question 33 there, the correct option is B. You want to note that when they say lodestone, this, right? You want to note that lodestone is a piece of iron that acts as a magnet. And since it's a piece of iron that acts as a magnet, usually it will point north-south when suspended freely. So the correct answer here is B, north-south when suspended freely. That's the correct answer. Okay, next up, question number 34. 34 says a voltage source delivers 240 volts RMS, that's root mean square, to a 1200 watt plate. What is the RMS of the electric currents? A, 100 amperes, B, 50 amperes, C, 2.5 amperes, D, 5 amperes. So how do we solve this question? To solve this question, the first thing we'll do here is let's list out our parameters. The first thing you're given there is VRMS, that's voltage in RMS, as 240 volts, and then you have watts. When you have 120 watt, watt represents what there? Power. So VRMS 34, let's see this, 34, we'll have that VRMS, root mean square voltage, that's 240 volts, so 240 volts. You have power P as equal to 1200, so 1200 watts. We know it's power because the SI unit is watts. That's how we do. Now, having said that, the first thing we want to do here is that I want to get the Vmax. All right. In calculating power, we don't use VRMS. No, we use Vmax. That's what we do. Because power, as we know, power is equal to I times voltage. That's current times voltage. But the voltage here is the maximum voltage or peak voltage, not RMS voltage. So let's get maximum voltage. So max voltage. So maximum voltage, max voltage. We call this Vmax. How do we get max? Well, the formula is simple, that Vmax is equal to VRMS times root 2. That's all, right? To get the maximum voltage, just multiply the VRMS by the square root of 2. We were saying that Vmax is equal to VRMS is 240 times the value of what? Root 2. And if you do this, 240 times root 2, you'd have your value as 339.4 volts. This is the maximum voltage. With this, we can get the value of power. Or from here, we can say, but record that power P is equal to the product of current times voltage. This current here is maximum current. This voltage here is maximum voltage. So in essence, I max, all right, I max is equal to get I here, divide here by voltage, divide here by voltage, this cancels this. So I is equal to power all over maximum voltage. Let's put that down. So it becomes power all over V max, maximum voltage. So I max then is equal to the value of the power is 1200 all over V max. That's about 339.4, 339.4, and that's equal to, let's take in this value here. If you punch this value here would be equal to approximately you have 3.54 amperes. This is the approximate value of I max. Now, in the question, we are asked to find the RMS value of the current. And we know that just like you have that from here, you have that V max is equal to VRMS times root 2. In the same way, I max, so I max, the same thing will be equal to IRMS, which you're asked to find, times root 2. So to get the value of IRMS, I'll divide here and also divide here by root 2. Square root of 2, square root of 2, this cancels this. So that's equal to, so IRMS, it's equal to I max all over root 2. And that's equal to, what's the value of I max? The value of I max there is 3.54, this, all over root 2. And if you do this, you have your value there as 2.5 amperes. This is the value of IRMS. All right, 2.5 amperes. Let's see. Yep, that's C. So the correct answer here is option C, 2.5 amperes. Okay, next up, 35. The following statement is true about force. Number one, it is a physical quantity that denotes ability to pull, push, twist, or accelerate a body. That's number one. Number two, it is a product of its mass and acceleration. That's force equal to mass times acceleration. Number three, the SI unit of force is Newton. Okay. Number four, it has a dimension of ml t to the power minus 2. So which of this is the correct answer? Let's analyze them one after the other. First things first, force. They said it is a physical quantity that denotes the ability to push, pull, twist, or accelerate a body. And this is actually true. All right, so the first one there is true. Second one said is a product of mass and acceleration. So we have this. All right. From Newton's second law, we know that this is true. So 2 is also true. Number 3 says the SI unit of force is Newton. Very obvious. So that is also true. So 3 is true. Number 4 says it has a dimension of ml t to the power minus 2. And this is also true. Recall that for force, F, force is equal to mass times acceleration. If I want to bring in units, we said force is in Newton, but then if you break Newton down to its lowest unit, mass here is capital M times acceleration is measured in meter per second squared, so ms to the power minus 2. We said mass is capital M times M here, this small m is meter, and meter measures length, so length, s is seconds, this one here, and seconds measure time, so t to power what there, minus 2. That becomes m times l times t to the power minus 2, which is simply ml t to the power minus 2. This is the dimension for force. So let's see. ml to the power minus 2. Yes, that means 4 is also correct. That means all of them are correct. So the correct option here is B. I III, and IV. Yes, all of them, they are all correct. All right. Next up, question number 36. 36 says the displacement D produced in a glass block of thickness small t and the refractive index small n when an object is viewed through it is, you have option A, option B, option C, and option D. So how do we solve this question? Now you want to note that they mentioned refractive index and they also mentioned a glass block of thickness n. Let's bring this up. Recall that for 36, so 36, you want to note that for a glass block, right, refractive index n is equal to, we'll use the concept of saying real depth, that's real depth all over apparent depth. Right, and that's equal to, real depth is simply the thickness of the glass block. That's the real depth. And they give us that as T all over. For the apparent depth is the difference between the thickness and D there. And we said D simply represents what there? Displacement. In essence, apparent depth is simply T minus D. So you want to take note of this formula for a glass block, that refractive index N is equal to T all over T minus D. Now, if you work on this, we have that N it's equal to T all over T minus D. Let's make D subject of the formula. This is all over 1. So you have N times T minus D. That becomes N into T minus D is equal to T times 1. That's T. Let's expand this bracket. N times T gives you Nt minus N times D gives you Nd is equal to T. To solve this, we'll move Nd over here and move T over here. So what you have become Nt, this is plus T, moves over here becomes minus T is equal to, this is negative Nd, moves over here becomes positive Nd. That's positive Nd. So we have this. All right, the next thing here I want to do is that to get the value of D, we'll divide both sides by N. All right, if I divide both sides by N, this and then this, right, by N, and then N, this will cancel this. So what do I have there? I have that D is equal to NT. Of course, you can separate this as this and this. That's all over N minus, and then this and this, which is T over N. This is mathematically correct. From here, this will be equal to N cancels N. You're having T minus T over N. So D will be equal to, bring out T from here. If I bring out T, that means I have T divided by T. That gives you 1. 1 minus, you have this one too, divided by T. That's T over N divided by T. To solve this, division change to what there? Multiplication, then 1 over T. That's how you solve this. And this will cancel this. You're left with 1 over N. So it becomes 1 over N. So you have D as being equal to T into 1 minus 1 over N. So do we have any option like this? T into D into T, or D is equal to T into 1 minus 1 over N. Let's see if we have this option. The displacement produced is, that's T into 1 minus N. The correct option here is C. C is the correct option for this question. All right. Question number 37. 37 says, in a resonance tube experiment, if the fundamental frequency of the vibrating air column is 280 Hz, the frequency of the third overtone is A, 70 Hz, B, 840 Hz, C, 1120 Hz, and then D, 1960 Hz. So how do we solve this question? Let's take down the parameters here. In this question, they gave us only 280 Hz, which is this one here. And they said it is what there? The fundamental frequency. This question is under sound waves. So 37, let's take this down. 37, you want to note that the fundamental frequency is given by F naught, and F naught's value is equal to 280 hertz. So this is equal to 280 hertz. You have this. You have to find the frequency of the third overtone. So you want to know that the third overtone is also called the fourth harmonics. So let's call the third overtone, let's call it FT3. All right. This is equal to 4 times, is the fourth harmonics. All right. So it becomes 4 times the value of F naught. That's how you do it. Okay. So the third overtone is 4 times F naught. The fourth overtone is 5 times F naught. That's how it's done. All right. Okay, if I put in the value there, it becomes 4 times F naught. That's equal to 4 into F naught is 280. And that's equal to, so 4 times 280, if you punch that value, that will give you a value of 1120. Its frequency is hertz. All right. So note that for the third overtone multiplied by 4, for the fourth overtone multiplied by 5, for the fifth overtone multiplied by 6, for the second overtone multiplied by what? 3, just like that. All right. So you have 1120 hertz. You want to note that this is a past question revision video. All right. If you want the full detailed lecture on sound waves, do well to check my playlist or our playlist on JAMB and post-UME classes. All right. So go to playlist, look for the JAMB slash post-UME, look for the JAMB and post-UME classes, and you get full lectures for all of this. But for this question here, the answer is 1120 hertz. So let's take down this answer. So which option is 1120 hertz? That's option C. So C, 1120 hertz is the correct answer. All right. Next up, question number 38. 38 says, which of the following diagrams shows the correct direction of the magnetic line of force of a vertical wire XY carrying a current I? You have option A, option B, option C, and option D. So which of these is the correct answer? So for this question here, the correct answer actually is A, right? It's A. This question here is under magnetic field and the magnetic line of forces. And it is A because from the right hand rule, the thumb is usually along the current upward from Y to X, and the magnetic field forms concentric circular field lines around the wire. And it is option A that correctly shows the circular lines, as you can see here, all right, and circling the vertical wire. So hence option A is the correct answer. Next up, question 39. Question 39 says, an ebonite rod rubbed with 4 attracts a glass rod rubbed with 6 because A, ebonite has a negative charge while glass has a positive charge. B, ebonite has a positive charge while glass has a negative charge. C, both have negative charges. D, both have positive charges. Now, for this question here, we want to know that for them to attract, they must be of opposite charges. So, option C, saying both have negative charges, cannot be the answer. Option B, saying both have positive charges, cannot be the answer. For them to attract, as the question says, they must be of opposite charges. All right. So, which of them is negatively charged and which of them is positively charged? So, you want to note that the ebonite rod is usually negatively charged while glass is positive charge. So in this question here, option A is the correct answer. All right. So the ebonite or the ebonite rod has a negative charge. Meanwhile, the glass has a positive charge. And since they have opposite charges, they will attract. That's the concept. Okay, the last question for this video. Question number 40. Now 40 says a student is at a height 4 meters above the ground during a thunderstorm. Given that the potential difference between the thunder cloud and the ground is 10 to the power 7 volts, The electric field created by the storm is, you have option A, option B, option C, option D. Now, judging by the unit, you can see Newton Coulomb to power 1. That's Newton per Coulomb. From here, question number 40. We know that electric field E, they said it's Newton per Coulomb. That's simply equal to Newton is force all over Coulomb. That's for charge. So the unit for the formula for electric field E is simply force over charge. But in this question here, we're not giving force, we're not giving charge. You also want to note that electric field can still be expressed as the ratio of potential difference. All right, still something as potential difference. So I'm going to do this potential difference all over height. So please take note of this formula, all over height. So this formula is also there. So if this is true, potential difference over height, let's see how we can get this. What's the value of the potential difference? Let's see again. They give us potential difference is the one in volts. That's 10 to the power 7 volts. And the height, there's 4. So it becomes 10 to the power 7. That's 10 to the power 7 all over the height is 4 meters. Let's see what we have there. So I'm going to get my calculator and I'll punch 10 to the power 7 divided by 4. This would give you 2.5 million basically. 1, 2, 3. So you have this. Again, electric field is usually in Newton per Coulomb. Newton per Coulomb. Express this in standard form or in index form. What do you have? 2. Let's put a point here. All right. This is now 2.5. So 2.5 times 10. How many times do I move? I'll move 1, 2, 3, 4, 5, 6 times 10 to the power 6 Newton per Coulomb. So my answer there is 2.5 times 10 to the power 6 Newton per Coulomb. That's option C. So yeah, option C, 2.5 times 10 to the power 6 Newton per Coulomb is the correct answer. Okay. 41 here says a cell of internal resistance small r supplies current to a 6.0 ohm resistor and its efficiency is 75%. Find the value of R. Okay. A, 8.0 ohms. B, 4.5 ohms. C, 2 ohms. D, 1 ohm. So how do we solve this question? Now for this question, let's take parameters. So 41. So 41. They gave me efficiency E as equal to 75, of course, in percentage. They also they said a cell of internal resistance, small r. So internal resistance, which we are asked to find, small r is equal to unknown. They said supplies current to a 6.0 ohm resistor. Now, this 6.0 ohm resistor is the external resistance. So external resistance R, capital R, is equal to 6 ohm or 6.0 ohm. Basically, you're asked to find the value of small r. And how do you solve that? You want to record that E is equal to capital R, that's external resistance, all over the sum of external and internal resistance. So this is what you have. Now let's solve for this. The value of E is 75%. And of course, this is all over 1. If I cross multiply E times this, you have E times external resistance plus internal resistance is equal to capital R times 1, which is capital R, that's external resistance. We have to find the value of small r. And what do you do here? Divide here by E, divide here by E. From here, this cancels this. So R plus R is equal to R all over E. To get the value of R, I'll move small r, I'll move capital R here. That means small r, internal resistance, is equal to external resistance, capital R, all over efficiency, minus, right, this is positive, moves over the equality sign, becomes negative R. Let's impute values. This is equal to capital R, the value is 6. So 6 all over. Now the value of E here, don't forget we said is 75%. We'll convert this. 75% is simply 75 all over 100, and that's equal to 0.75. So E is actually 0.75, which is 75%. So all over 0.75, 75% minus R. The value of R again is 6. That's external resistance. And this will be equal to, so let's punch 6 divided by 0.75. That's about 8. So 8 minus this 6 here, and that's equal to 2. Resistance is in ohms. So that means the internal resistance, small r, is equal to 2 ohms. So R is 2 ohms. So which option is that? Let's see. That is C. The correct answer here is C, 2.0 ohms. Question 42. If a ball is released from a height of 20 meters, how long will it take to reach the ground? Assuming G is equal to 10. A, 2 seconds. B, 3 seconds. C, 3.5. It should be 6. So I'll put seconds. Right? So seconds. And then D, you have 2.4 seconds. So how do we solve this particular question? Now, let's list our parameters. They said the height here is 20 meters. So for 42. So 42, the first we're given there is height, h, as equal to, they said the h there is 20 meters. That's 20 meters. Take acceleration due to gravity as 10 meters per second squared. You're asked to find what exactly they said. How long would it take? So how long, talking about time. So T is equal to unknown. Now, this question is under free fall, all right? We've also discussed the concept of free fall. Check the JAMB and post classes, all right? Go to playlists, check the JAMB and post classes under motion. We've discussed this particular topic. And for this question here, we use the equation of motion. Now recall that one of the equations of motion says that S is equal to ut plus half at squared. We're using the same equation here, but in the concept of free fall. It is free fall because if you look at the equation, they said a ball is released from height. So basically, this ball, let's say you have a ball here being released from height, it is falling vertically downwards. And when a ball is moving vertically downwards or vertically upwards, we'll use the free fall concept. And in free fall, S is equal to H. So have that H is equal to UT plus half. Then you have A, all right? A becomes G in free fall. So I'll replace A by G and T squared. Now you want to know that since the body is being released from a height, that means the body is falling downwards. And when it's falling downwards, this becomes plus. Since the body is falling downwards, the sign here becomes positive. All right. Then again, looking at the question, they said a ball is released from a height. When they say a ball is released from a height, it means the ball was stationary and then it was released. In essence, the initial velocity u will be equal to 0. If u here is 0, it becomes 0 times t, and this gives you 0. So you have that h is equal to half into g. The value of g is 10, and then t squared. What's the value of h again? That value is 20. So you have that 20. It's equal to half of 10 is 5. So 5 t squared. Divide here by 5. Divide here by 5. This cancels this. You have that t squared is equal to 20 over 5. That gives you 4. To get t becomes the square root of 4. Take square root, and that gives you 2. Time is in seconds. So t becomes 2 seconds. So in essence, for this question, the correct answer there is for 42 is 2 seconds. That's option A, 2 seconds. Next up, 43. 43 says an object O lies at a distance m in front of a concave mirror of focal length f. If m, right, that's the distance, is lesser than the focal length, then the final image obtained will be A, virtual and diminished, B, magnified and erect, C, real and inverted, D, diminished and erect. Now you want to note that if the object distance m is less than f, what will happen is simple. For this case, the final image obtained will be number 1, it will be virtual. Number 2, it will be erect. Number 3, it will be magnified. So you have this. It will be virtual, it will be erect, it will be magnified. So which of these options matches all of this? This one says virtual and diminished. No. This one says magnified and erect. Yes. B works. C says real and inverted. No. D says diminished and erect. So the correct answer would be B, magnified and erect. It matches magnified, it matches erect. But to take note that it can also be virtual too. All right. But let's take B. That's magnified and erect. That's the correct answer. Okay, next up, question 44. It says a body dropped from rest to reach the ground in about 0.15 seconds. Calculate the height from which it is dropped. Take G as 10 meters per second squared. A 0.25 meters, B 3.5 meters, C 1.35 meters, D 0.11 meters. So how do we answer this question? Again, we use the same concept as we used initially. Now, in solving this, I said a body is dropped from rest to reach the ground in about 0.15 seconds. So 44, you give us the time there, T, as equal to 0.15 in seconds. You're also giving G, or you're told to take G as equal to 10 meters per second squared. What else? They said you should calculate the height from which it is dropped. So H, height from which it is dropped, H is equal to unknown, right? So how do we solve this question? Again, we'll still use this same equation. Recall that H is equal to UT plus half GT squared. Now they said a body dropped from rest. And when a body starts from rest, its initial velocity, U, is equal to 0. Same concept. So this will give you 0. In this case, they give us okay, we have to find height. All right, height is equal to half 1 over 2 times G. The value of G is 10 times T squared. T squared is 0.15 all squared. All right, so get your calculator and punch this correctly. 1 over 2, open a bracket, times 10, open a bracket, times 0.15 squared. All right, punch this correctly. If you punch this correctly, your answer here will be 0.11 approximately. 0.11 meters in two decimal places. So do we have 0.11 meters here? Yep, that is option D. Option D, 0.11 meters. That is the correct answer. Next up, question 45. 45 says an object is placed in front of two plane mirrors inclined at an angle of theta. If the total number of images formed is 7, find the value of theta. A, 30 degrees, B, 45 degrees, C, 51 degrees, D, 90 degrees. So how do we solve this question? So take note that for 45, the number of images formed, N, is given by 360 all over theta minus 1. Here's the formula for that, all right? And they said 7 images were formed. So N is equal to 7. So you have 7 is equal to 360 all over theta minus 1. Move minus 1 over here, it becomes 7 plus 1, and that gives you 8. So you have that 8 is equal to 360 all over theta. That's the angle. From here, this becomes all over 1. So you have 8 times theta gives you 8 times the angle there, theta. It's equal to 360 times 1 gives you 360. To get the angle there, theta, divide here by 8, divide here by 8. This cancels this. So theta, it's equal to 360 divided by 8. You have 45. Of course, angle in degrees. So that means they must be placed at 45 degrees. So do we have a 45 degrees there? Yep, that's option B, 45 degrees. So the value of theta here, that's the angle that it has to be placed for you to have 7 images, is 45 degrees. Okay, 46. Question 46 says efficiency of a transformer is equal to A, efficiency E is equal to secondary coil divided by primary coil times 100%. B, efficiency is equal to mechanical advantage all over velocity ratio times 100%. Now, this would have been true, but this is not for a transformer. C says efficiency is equal to number of turns in secondary coil divided by number of turns in the primary coil times 100%, which is still not it. Then D says efficiency is equal to power developed in the secondary coil divided by power developed in the primary coil. So you have this. Now this is true, but you're lacking the times 100%. So this, of course, times 100%. So for this question there, the correct option is D. All right, so D is the correct answer. Next up, question 47. What type of electromagnetic radiation can be used to take photographs in the haze? A. Radio waves. B. Infrared rays. C. Visible light. D. Gamma rays. For this question here, the correct answer is infrared. All right. Infrared ray is the type of electromagnetic radiation that can be used to take photograph in the haze. Now, if you're wondering what a haze is simply an atmospheric condition where fine dry particles like dust or smoke or even other pollution reduces the visibility of the atmosphere. All right, hence you cannot see clearly because of perhaps dust or smoke or other pollutants. So the type of electromagnetic radiation that can still be used to take photographs in such an atmosphere is the infrared rays. All right, so take note of this. Next up, question number 48. 48 says the diagram below shows a closed square box of side 0.5 meters in a uniform electric field E in the direction shown by the arrows. So you can see the direction this way here, moving from left to right. What is the flux? That's electric flux of the box. Okay, so before we look at the options, you want to note that electric flux is actually this, and the unit is voltmeter. So voltmeter, that's Vm, voltmeter. The alternative unit is Newton meter squared per coulomb. That's Newton meter squared per coulomb. All right, so these units are not correct. That is if they're asking for the electric flux, right? So you have this either voltmeter or Newton meter squared per coulomb. Right, you have your options 0.00, B 0.2, C 0.5, D 2.0. Now, how do we solve this question? You want to note that for electric flux, the formula there is that you have this. This is the unit, or this is the symbol. This is equal to phi is equal to E A cos theta. All right, this is phi. Phi is pronounced or is spelled PHI. That's phi. So EA cos theta, what do you have there? This is equal to, what's the value of E there? The value of E, let's see. Oh, they said electric field, just E. All right, so leave this as E. Then you have A. For A is simply area. And if they give you the side as 0.5, and they said is a square box. So for a square box of size 0.5, the area becomes 0.5 times 0.5, which is 0.5 squared. Also, you now have cosine of theta. What's the angle there? Now, if you look at this, all right, if the field is this way, now when you have this moving in this way here, this way, you want to see that this is actually perpendicular, all right, to this. So the angle there is 90 degrees because the field is moving perpendicular to your vertical line. So it becomes cos, the theta becomes 90. All right. So let me explain this again. First things first, you have that phi is equal to electric field times area, then cosine of the angle with which the electric field is moving. This is equal to, the value of E is not given. We'll take it as E. Again, A is area. They said one of the side is 0.5 and it's a square side. So area becomes this one side 0.5 times the other side again 0.5, which gives you 0.5 times 0.5, that's 0.5 squared. Then cosine of the angle. What's the angle there? The angle, looking at this, all right, if I place my vertical line, this field is flowing this way, which is 90 degrees. So cos 90. So you have this as 90. This is equal to E into 0.5 squared. If you do 0.5 squared, you have your answer as 0.25. So 0.25 into cosine of 90 gives you 0. So that gives you 0. All right. And if you multiply this, you have that phi, which is electric flux, is equal to this times 0 gives you 0. So the answer there is 0. Right. Now you might want to say 0e, but 0 is 0. So your answer there is 0. So let's see which option there is 0. So for 48, the correct option here is A, 0.00. Right? So yeah, that's your answer. 49. If a normal sighted person loses the sight of one eye, he cannot A. Judge the distance of an object. B. See clearly a near object. C. B. See clearly a near object. C. Decode the shape of an object. D. He cannot see with it. All right. Now, if a normal sighted person loses the sight of one eye, then what happens? It's very simple and very clear. The fact now is that he cannot even see with it. Talk more of judging the distance or seeing clearly or decoding the shape. He cannot even see with that eye because you've lost sight of that eye. All right. So, of course, the answer there, the correct option is he cannot see with it. All right. If you say he cannot judge the distance of an object, that means probably he could see, but not very well. That means he cannot judge distance. If you say he cannot see clearly a near object, that means he can probably see, but not very well. If you say decode the shape of an object, what you're trying to say is that probably he can see, but then he cannot see clearly to either decode the shape of an object. But the thing is this, they said if the person loses the sight of one eye, if you lose the sight of one eye, you cannot even see with it at all. So the correct answer there is D. He cannot see with it. That's the most correct option. All right, our final question, 50. 50 says, which of the following is a vector quantity? A, temperature gradient. B, mass. C, work. D, time. So which of these is a vector quantity? For this question here, the correct answer is A. A is temperature gradient. Now, if temperature gradient is a vector quantity, it means it must have magnitude or numerical value and it must have direction. So what is the direction of temperature gradient? You want to take note that a temperature gradient points in the direction of the greatest temperature increase. So that's your direction. So for temperature gradient, it has a value, and for the direction, it will always point in the direction of the greatest temperature increase. So that's why temperature gradient is a vector quantity. Mass, work, and time are all scalar quantity. All right. All right, guys. So this is the end to the 2021 JAMB Physics examination questions. We'll also provide the past question and solution for other year in our subsequent videos. Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.jonahemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. All right. For the comment, I gave you a task, question number 11. Solve it. Leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe. Hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.